Hey guys, we shall solve another problem on LeetCode now. The given problem is given n cross n star n matrix grid of zeros and ones only. So they have given us with a matrix n cross n, that is nothing but square matrix that either contains 0 or 1, only the binary values. And we want to represent this grid with a quadri. They want to represent this grid, this matrix with a quadri. So what is quadri? Usually we draw the trees if it is a node and we draw the two children again for this node, two children and so on, right? But quadri as a name represents if there is a node, it should contain four children. So the here aim of the program is nothing but to convert this matrix into this quadri. How do we do that? The given return the root of the quadri represented in the matrix. Then notice that you can assign the value of a node to true or false when ESLIF is false and both are accepted in the answer. So what is ESLIF? You could see here there are two parameters, val and ESLIF values. So when you convert this matrix into a quadri, you will be generating a node, and that node contains two parameters. One is val, another is ESLIF. So this val contains value of the grid. That is nothing but if a matrix contains entirely 1, then the value of the grid will be 1 or true, because this val and ESLIF are set to Boolean values. So if the entire this val value will become true if the node represents a grid of ones. So if all elements of the matrix is 1, then the value of the val will be true, or false if the node represents grid of zeros. If all the elements of this matrix is 0, then the value of the val will be false. Why? Because all the elements are of zeros. And each leaf, this is set to true if a node is a leaf node, else it will be set to false. So each leaf, if a node which we generate is a leaf node, then yeah, each set will be assigned to true. If it is not a leaf node, then it will be assigned to false. That means it is a non-leaf node. If it is a non-leaf node, it's a parent node and it will further contain children. How many children it will contain? It would contain four children because we are constructing the quadri. In the normal tree, we used to have either one or two children, but here, since they have mentioned it's a quadri, it must and should contain four children for a non-leaf node. If it is a leaf node, just terminate over there and set the value equal to true. If it is a non-leaf node, then set the value of the east leaf to false. And now we'll come to the sentence. Notice that you can assign the value of a node to true or false when each leaf is false. So if each leaf is false, then that means it's not a leaf node. It's a non-leaf node. And at that time, you can assign the value of a node to true or false. So if each leaf equal to false, then this value of the val can be either true or false. Why is it true or false? I shall explain this later now. So So this is the example which they have given. So these are the two parameters of a node, as I said, and if it is a non-leaf node, it should contain four children. So what are those four children? It is nothing but top left, top right, bottom left, bottom right. These four children are with respect to the matrix in this format: top left, top right, bottom left, bottom right. Now, how will we get to know whether the given node is a leaf node or not? How will we get to know? That is done by, if the current grid has the same value, that is all ones or zeros, then set each leaf equal to true. So if this is the matrix, and if all the elements of the matrix is 1, or consider all the elements of the matrix is 0, that means it is a leaf node. And by if we come to know it is a leaf node, what do we do? We set the value of the val equal to value of the grid. So imagine all these elements of the matrix is containing 1 as the number. Then the value of the val will be 1. 1 means it's a true, and each leaf will be set to true because it's a leaf node. That is what they have told here. And set the four children to null. Why are we setting the four children to null? Since this is a leaf node, there will be no more children to that node, and so we set the value of the children to the null. What if the current grid has different values? The current grid has different value, matlab 0, 1, 1, 0, any values. Then what can we do? Then set each leaf equal to false. That means that matrix is a non-leaf node. It's a not a leaf node. So we set the value of is equal to false and set val equal to any value. Why are we setting the value equal to any value? Because as I said, this matrix is not containing only zeros or only ones. It contains both zeros and ones. Thus, we can assign the value of the val equal to 0 and 1 since both are present in the matrix. If it is a leaf node, then it will contain only zeros or ones. At that time, we have to assign the value of the val equal to value of the grid only. That is it may be 1 or 0. Then divide the current grid into four subgrids as shown in the figure. Why are we dividing the current grid into four subgrids? Since this is a non-leaf node, it should contain further children. How many children it should contain? Since it's a quadri, it should contain four children. That's why we are dividing this current matrix grid. Grid is nothing but they have mentioned the name of the matrix as grid. So you are dividing this matrix into four sub-matrices, four grids, where each grid will be called as top left, top right, bottom left, and bottom right. So once you divide this matrix, then again you have to apply the same function over here as well. That will check through an example. So let us consider this example now. This matrix, as I said, we have to check two conditions. Whether all values equal to 0 or 1. See, if all the values are 0 here, no. 0, 1 both are there. If all the values are 1, no. So that means this is a non-leaf node. If this is a non-leaf node, what we have to do? We have to assign the value of val equal to either true or false, either 0 or 1. It can be anything because this matrix containing both zeros and ones. And each leaf will become 0. Why is leaf equal to 0? Because this is not a leaf node since all the elements are not same in this matrix. So if it is not a leaf node, then what does it indicate? We have to generate children for them. How many children? Four children because since it's a quadtree. How do we generate the children? By dividing the tree into or by dividing the matrix into four submatrices. So once you divide the four submatrices, this is the top left, top right, bottom left, and bottom right. So first, second, third, and fourth. Four submatrices are there. Then again recursively we have to check the first submatrices, second, third, and fourth. So go to the first submatrices. It contains only the value 0. Hence all the matrix of the elements is same. That is nothing but 0. That means this is a leaf node and value of the value will be equal to value of the grid. Value of the grid is 0 in this case. This is with respect to top left. Next, coming to the top right, you can see only one element is found and that element is nothing but 1. Hence, all the elements of the matrix is same. So, the value of the val will be equal to 1 and this is a leaf node since so leaf each leaf will be equal to 1. Next, go to the bottom left. Similarly, it contains only one element and that is 1. Hence, value of the val will be equal to value of the grid, that is 1. And it since all elements are same, it's a leaf node and we set the value of each leaf equal to 1. Similarly, to the bottom right as well, it contains only one element 0. So that means all elements of the matrix is 1. But it contains only one element. All elements of the matrix is same. So in this case, the matrix element is 0. So the value of the val will be equal to 0. And it indicates, since all elements are same, it indicates it's a leaf node. Hence, we initialize the each leaf value equal to 1. So this is an example we have got to know. Once you are done with the leaf node, you are done with the problem. So initially they had the matrix and we got to know all the elements are not same in this. Thus we got to know the each leaf, this is not a leaf node. So each leaf value is 0 and value of the val will be either 0 or 1. After this, you have to divide this matrix into 4 submatrices as you see here and compute the same functionality for all the 4 submatrices as well. So all the 4 submatrices contains only one element, hence all the 4 submatrices are nothing but leaf nodes. So you set the value of leaf equal to 1 and value of the val will be equal to corresponding value of the grid. Hope you have understood with the simple example. Now we'll move to a bit complex one. So here you can see the given matrix. At first we need to check whether all the values are 0, 1, both are, it contains both the values 0 and 1. Hence we got to know that this matrix is not a leaf node. So the value of the leaf, if you see here, leaf equal to 0. Why is it 0? Since all the elements of the matrix is not equal, that means it's not a leaf node. So the value of the each leaf will become 0 and value of the valve can be either 1 or 0 as well because matrix is containing both the numbers. So after you got to know that this is a non-leaf node, you have to divide this matrix into 4 submatrices. So equally divide the matrix into 4 submatrices. So consider the first is the top left, top right, bottom left, bottom right. 1, 2, 3, and 4. Top left, top right, bottom left, bottom right. Now you consider this top left matrix. So if you can see top left matrix, it is containing all the elements as same only, that is nothing but 1. So that means this is a leaf node and we set the value of each leaf equal to 1 and value of the val will be equal to value of the grid, that is 1. Value of the grid means value of the matrix. Next go to the top right. But so here you can see it contains both zeros and ones. So that means this is not a leaf node. Hence we set the value of each leaf equal to 0 and value of the val can be either 0 or 1. So once you got to know that this is a non-leaf node, again you have to divide this matrix submatrix into another submatrix, another 4 sets of submatrices. So that is what done over here. So once you divide this another 4 submatrices, you have to check all the 4 matrices with the same methodology. So the first submatrix top left, top right, bottom left, bottom right. Top left, top right, bottom left, bottom right. If you see the top left submatrix, so we got to know this top right is not containing all elements same, hence this is a non-leaf node. So we are doing the 4 submatrices as you can see here. Now we are seeing the top left, that is nothing but this one. Top right is this. Similarly, bottom left and bottom right. Bottom left and bottom right. So if you see the top left, all the elements are containing 0. Hence, this is a leaf node. We will set the value of the leaf equal to 1 and val value will become 0 because it is nothing but the value of the grid. Again, top right, if you see again same thing as the top left only. All the values are same and it is nothing but 0. So val value is 0 and is leaf equal to 1. If you go to bottom left and bottom right, bottom left contain all values same. So each leaf will become 1 and value of the value will be equal to value of the grid, that is nothing but 1. Again bottom right, if you go, each leaf equal to 1 and value of the val will be equal to value of the grid, that is nothing but 1, since all the elements of the harvest submatrix is same. So we are done with this second submatrix entirely. Now we shall move to this bottom left. So if you see this bottom left, all the elements are same, which is 1. Hence, this is a leaf node. We set the value of the, you are done with this part now. So we'll move to this section and this section. So all the elements of the bottom left submatrix is same. So leaf node is, it's a leaf node and the value is set to 1 and value of the value equal to value of the grid. Again, we go to the bottom right. Again, you can see all the values are set to 0. That means it's a leaf node. You set the value of leaf equal to 1, value of the value equal to value of the grid. Hope you have understood this problem. So we shall logically see how to solve the problem with the code now. So we need two functions over here. One is all values. This all values function is required to check whether all the elements of the matrix is same or not. If it is same, then return true. If it is not, return false. It is all values. We are checking all values function to check whether all elements of the grid is same or not. Another function you need for solving this problem. So in other the solve function, what we will do, will check whether all the values is returning true. If all values is returning as true as the answer, then that means it's nothing but a leaf node. So all values, if it is returning true, that means all elements of the matrix is same. If all the elements of the matrix is same, that means it's a leaf node. By that time, you set the value of each leaf equal to true, because all the elements of the matrix are same and set the value equal to true. And value of the val will be equal to value of the value will be equal to value of the grid. Value of the grid. How grid of its value. So this is one case if the all elements of the matrix is equal. What if all elements of the matrix is not equal? If all elements of the values is not equal, then comes the else part. So here this all values function is returning false. That is, all the elements of the matrix is not same. That means you set the value of each leaf equal to false. So each leaf will become false. And next value of the val will be equal to either 0 or 1. I mean that's the boolean value actually, because if you see in the question they have told both, yeah, both leaf and val both are the boolean values. So value of val can be either true or false. It can be anything. So once you do that, here again, yeah, this is a leaf node, right? So you have to return the new node as well. Node. So here you create a node with these values in, and for that again you have to, since this is a non-leaf node, we will have to create four children for that. Top left, top right, bottom right. Four nodes for that. So four children will be created, and again you call the same solve function recursively. Why are we calling the same solve function recursively for four nodes? because in each node, again you have to check the same conditions, whether all the elements are same. If all elements are same, then it will be a leaf node, and you set the value of a leaf equal to true, and the val value will be equal to value of the grid. If this is not all the same, then again you have to divide this into four submatrices, so that each leaf will be equal to 0 and value of the val can be either 0 or 1. So you have to do until you get all the elements of the matrix is same, so that you have to reach the leaf node ultimately to build the quad tree. Now we will code the program for here. So as I said, we need a function all values to check whether all the values of the matrix are same or not. So that can be done as public, and this function will be returning boolean values true and false. So public boolean all values parameters are grid, and then comes the starting row, starting column. So if you see this part, this is nothing but 0 comma 0 starting point, and here it is 0 comma 8, 1 2 3 4 5 6 7 8. It is 8 comma 0, 8 comma 8. This is the entire matrix. So in this matrix, all the nodes are of not of same values, right? So we have to divide this into four submatrices. In that case, we have to get to know coordinates of these points as well. What are the coordinates? That is nothing but 0 plus half of the total length, plus 8 by 2, comma 0. Here again it is 8 by 2, comma 8. And if you see here, it's 0 comma 8 by 2. Here it is 8 comma 8 by 2. So all these things, if you see, this is the starting row, starting column, and ending row, ending column. So the four parameters would be starting row, ending row, then starting column and ending column. So all would be int only. So in this, what do we have to check? Whether all the elements of the matrix are same or not. So for loop int I equal to starting row I lesser than equal to till here. That is nothing but end row and I plus plus, since it's a 2 cross 2 matrix, two for loops we need. Int I j equal to starting column, j lesser than or equal to ending column, and j plus plus. Now we have to check whether the value of the grid are same or not. So here int val equal to int val equal to the we take the number of very first cell. So grid of SR and SC. So inside the for loop, we will need to check if grid of I comma j not equal to val, then return false, else would return true. Return true. So you need to be careful while giving this if condition. What if I give equal to val and then here true, and here if I give false. So if you observe, it will start with the follow. We'll consider this example only. It will start with the follow, starting row and starting column. If grid of I comma j equal to val, yeah, it is true. So if the condition becomes true, we are returning the statement true. The loop will stop, terminate here itself. It won't consider the further other elements in the matrix. So that's why we should be careful. So we have to give the contradictory condition here so that until you get the not equal value, you should iterate to the matrix. If all the elements are covered and we don't get this false value, then only we return true. Else, at somewhere middle in the matrix, if you get a false as a return value, then the for loop will stop there itself. That means it shows it is a non-leaf node because all the elements of the matrix are not same. So this is the function for checking whether all the values of the matrix are same or not. So initially you initialize the value of the val equal to starting one. So if the same starting one is starting value is equal to the elements of the entire other matrix value, then that means you return true, else we return false. So if this returns true, that means all the elements of the matrix are same, and that indicates that it's a leaf node, and we set the value of the value equal to grid. Else we set the value of the value equal to any value, and leaf node will each leaf will be false, and there where they will create four other sub matrices for the given matrix. That means four children node for the parent node. So once we are done with the checking of whether values are true or false, now again we need the function which I told we need to implement the property of generating the nodes. So for that function public node, because we'll be creating the nodes, we'll be converting this matrix into tree, right? So we'll be creating the nodes, public node sol of the same parameters also. We'll go into this. So once you're done with this, now you have to check if all values of grid of SR comma starting rows, ending row comma starting column and ending column is equal to true. If all values return the true, that means all the elements of the matrix are same. If all the elements of the matrix are same, if all the elements of the matrix are same, we have to set each leaf equal to true. When is it's a leaf node, and we set the value of the value to the value of the grid. So if all the values returns true, that means all elements of the matrix are same. We need a boolean val. Why are we requiring boolean val? Because boolean is the type of the val which they have given in the question already. It should return. Otherwise, the program won't work. Bool val equal to true. We would bool val will be declared if yeah. So all the elements of the value will either return 1 or 0. If it returns 1, then the value of the val will be true. If it returns 0, value of the val will be equal to false. So if grid of SR and SC equal to 1, then we set the value equal to true. which they mentioned here. Else we set the value equal to val value equal to false. This is one condition. So now initialize the value of val. How do we initialize the leaf? That we can do it directly when we are creating the new node, right? The value of the east leaf will be equal to true since it's a leaf node. True if it is a leaf node on the tree. Why is it a leaf node on the tree? Because all the elements of the matrix are same. That is either 1 or 0. So val value we have written. Now we will return new node which contains val value that is taken from here and east leaf value. East leaf value is set to. So if we take this example, this indicates the generation of this node. East leaf will be equal to set to true, any node, and val value will be value of the grid. So if you take this one, small 0 first grid, subgrid, the val value is true here, that is 1, and val value is true, that is nothing but 0. False here, it is because it's a 0, and east leaf equal to true because it's a leaf node. So this is condition if it's a leaf node. What if it is a non-leaf node? In that case, else part comes in. If this is a non-leaf node, then we set the val value to any value. Yeah, you set the val value to any value. So we can directly return the new node here. So node, creating a new node equal to new node of, it can be false comma false. This false indicates the value of the val and this is the east leaf value because this is not a leaf node. Even this can be written as node equal to new node of true comma false. It is very much the value of the val can be either true or false. Both are correct. They have given in the, yeah, notice that you can assign the value of val equal to true or false when east leaf equal to false. When east leaf is false, both are accepted in the answer. After this, after your so if you consider this matrix, you have generated the node of this has been generated. So after this is generated, now we assign the value of val and is leaf equal to false. If this is a non-leaf node, then we have to divide this matrix into four submatrices. So for that, we need four different nodes: top left, top right, bottom right. And for dividing the node, as I said, you see in this diagram 0, 0 and 0, comma 8 by 2. This half value is required each time because when we divide the matrix into four submatrices, we'll be dividing it by the middle of the half of the length of the rows of columns. So we shall declare and initialize another variable called half, that is nothing but ending row minus starting row divided by 2. So if this is 0, ending row is 0, and ending row is 8 and starting row is 0, the half value will be 4. So that we'll be able to compute the submatrices each time with the parameters half initialized to it wherever required. Now once you're done declaring this variable half and initializing it, we shall generate all the leaf nodes. Top left equal to, we will recursively call the same function. Why are we recursively calling the same function solve? Because in this submatrix also we need to check whether all the elements are 0. If all the elements are 0, then it's a leaf node and we set the value of each leaf equal to 1 and the value of val will be equal to value of the grid. If it is not a leaf node, leaf node, then again it would come to this else part. Oh, sorry, I made a mistake. Instead of writing it over here, we should write all these things in like else part. Yeah. Now it's proper. This is the main function. Um, okay. Top left equal to solve of grade, comma. So if you divide this matrix into four submatrices, 0, 1, 2, yeah, 0 to 8 is there. For the top right, if you see starting row and starting row and starting column are 0, comma 0. Ending row, ending column are nothing but um, 8 by 2, comma 8 by 2. So this will be starting row, comma starting ending row will be starting row plus half, and next ending row starting column and ending column will be starting column plus half. Similarly, you have to create node for top right as well. Solve of grade. So if you see top right, the starting row is nothing but the starting row itself. So SR, and ending row is nothing but starting row plus half. So starting row plus half. Next come to starting column. Starting column is starting column plus half. Starting column plus half, and ending column is nothing but ending column. So again similarly we have to do for bottom left equal to solve of grade, comma. So for the bottom left, starting row is nothing but starting row is here, starting row plus half. So starting row plus half. Ending row would be the ending row. Then starting column is nothing but starting column only. Ending column is ending column plus, sorry, starting column plus half. Lastly, the node for bottom right, all of grade. So starting row is starting row plus half. Ending row would be the ending row. Starting column will be starting column plus half, and ending column will be the ending column. So by doing this, we are creating all these children nodes for the parent node. Parent node is this one, and all the children nodes are this one. Similarly, again for this one, parent node is here created, children node is created here, and all these leaf nodes which are there, we are returning over here. So we are just calling the function again, and all these leaf nodes they are written in the in the first if condition. So this is the code. What we have done is at first we have to check whether all the elements of the matrix are same or not, and if it is same, then return true. If all the elements are not same, then return false. When you go to this solve function, here if all the elements of the matrix is same, that means if it is written in true, that means it is a leaf node. You set the value of each leaf equal to true here, and val value will be equal to value of the grid. So if the value of the grid is 1, val value will be true. If value of the grid is 0, else then value will be false. So both val and each leaf are the boolean values. After this, you go to the next part. If this is not the case, if all elements are not the same, in that sense it tells that this is not a leaf node. You set the value of each leaf equal to false, and value of the val can be either true or false, because the matrix would be containing both 0 and 1 in this case. So once you get to know this is a non-leaf node, you have to divide the matrix into four submatrices. So for dividing into four submatrices, four nodes, you need to call the function recursively, top left, top right, bottom left, bottom right, and give the corresponding parameters as such. So again, the condition would check here whether all elements are same. If it's the same, then you return that. Else again, you divide it. At the end, in the main function, you will return the function with the parameter grade, and the starting row is 0 and ending row is nothing but grade dot length. Then starting column is 0, ending column is nothing but grade dot length. So since you are calling this, the call will go here. Then you're calling all value function, which I call the values. If it is returning true, it will go here. Else, if it is returning false, it will do here. Here recursively you are calling again solve will go and recursively it happen until we get the leaf node. Since you are converting the matrix into a quadry in this case, so we'll run and check whether the test cases are passing or not. Illegal return new node equal to so I have made a mistake. Illegal start type of else. Illegal start type of L means low. Okay, so this should be capital. And any other thing? Yeah, we have to return the node here as well. Okay, we should start checking from again. Node values equal to okay, not it, only this. Then top left of this half and oh, this one should come here. Everything is fine. Return open and for the function starting open close. Okay, for the class as well you need a closing one. Open, open, close, close. Yeah, this is done. Okay, start here and close here, close here. Extra one not required. Yeah, yeah. So the test case have been passed. Now we'll submit and check. So the all the test cases are passed, and I hope you guys have understood this problem. We'll come up with another new problem in the next video. Thank you.